So today we discuss chapter 12 atom. Okay, so here we discuss chapter number 12 atom. Okay, so mainly here we study structure of atom. Structure of atom. Okay, so from start of structure of atom, here we know some fact about that. Okay, so here the J.J. Thomson, okay, named the famous scientist J.J. Thomson. Okay, J.J. Thomson was a charge elements identical for to all atoms. So, okay, so J.J. Thomson is a clear the concept here, put a concept for charge element in 1897, and that's a charge element for all atoms are identical. Okay, so all bodies are electrically neutral, and concept is that all body are neutral. So what signifies the neutral? So neutral means so equal number of positive and negative charges. Suppose if I 5 plus and here is a minus 5. If we added these two, we get a 0. Okay, so that means the neutral. So okay, if a body electrical neutral means equal number of positive and negative charges. That's the concept of J.J. Thomson model. It's a concept of J.J. Thomson concept of J.J. Thomson in 1898. Okay, so here some concepts look like that. Some watermelon model. So he proposed that some watermelon model. So what is watermelon model? So in that is watermelons look like this. Suppose this is a watermelon and here is some seeds inside that. Here perfectly designed seeds here. Okay, that's the seeds of watermelon. This black dot represents the seeds of watermelon. Okay, and these seeds, okay, this seed is the electron. Okay, these seeds represent the electron. Okay, and that positive charge. Okay, then the positive charge are throughout the distributed. Okay, throughout the volume of the watermelon. Okay, these are positive charge are distributed throughout the watermelon. So positive charge distributed throughout the watermelon. Okay, and these are perfectly shaped structure like these are seed structure of watermelon. These are the electron. Okay, so here and these are the electron bit of this negative charge here, and this model is called Plum and Pudding model. Okay, the study of distribution of electron and negative charge and positive charge, mainly the distribution of electron and positive charge. So here is the what is the watermelon model. Our father is established the important the plum and pudding model. Okay, plum pudding model. There is a concept is like that. If that plus is uniformly distributed throughout that volume of the watermelon, of the means actually this a watermelon is atom. This watermelon is atom. If atom is a watermelon, so the seeds is the electron positive are whole distributed in watermelon and electron in these are seeds of seeds with the electron. Clear? Then what is the plum and pudding model? And further, the condensed matter means that the solid or liquid, they, at all temperature they emit that EM radiation. Okay, and previous study, previous chapter, the dual nature of matter. Okay, dual nature means the electron have a particle nature and wave nature. So actually these are the electromagnetic radiation obviously. So electromagnetic radiation distribution, okay, that's the if a wave, so there is a wavelength toward the different intensity. In condensed matter, all temperature, condensed solid and liquid, they emit some radiation, and this radiation is a electromagnetic radiation, electromagnetic mainly, at several wavelength and toward the different intensity. So several wavelength and different intensity. So condensed matter okay, radiates EM radiation. If a radiation means there is a wave, so there is some wave. If a wave, so there is some wavelength and some intensity. Obviously, these are different wavelength and different intensities. Okay. So here the radiation, main concept from the radiation. This radiation, further study for radiation, is considered to be the due to the oscillation of atom and molecule. Okay, this radiation comes from to be the oscillation of atom and molecule. Oscillation of atom and molecules. Clear? If your atom or molecule vibrate, so there is some radiation. Like previous class we studied, previous class means the previous chapter, in a calm water, if I drop a stone in the pool and there is some undulation here, so if there is undulation, there is some oscillation here. Similar like that, if atom or molecules are vibrate, if they vibrate, so they create some oscillation, and means there is some radiation. Obviously, if the oscillation there is a radiation. Okay, so in 19th century, the characteristics of the spectrum of radiation. Okay, mainly after that starting of 19th century, after J.J. Thomson. So here the study of spectrum. So mainly here the study of spectrum. Okay, means there's a radiation. Mainly study of spectrum means study of radiation. Okay, so if I excited atom by electrically, okay, if I excited, okay, now if I atoms are excited electrically in a glass tube, such as a familiar like a neon sign or mercury vapor light, okay, only the certain discrete wavelength. We have some discrete wavelength like that. If excited excited atom uh, by electrically okay in glass tube such as a familiar neon sign, such as familiar neon sign or mercury vapor, neon sign mercury vapor. Okay, a light have some certain discrete wavelength. So these light have some certain discrete wavelength. Okay, there is some discrete wavelength. Okay, so study the spectrum radiation of hydrogen atom is for Balmer series. Further, we study in even progress in this chapter. So we study the what is the Balmer series. Okay, study of spectrum radiation of hydrogen atom by Balmer series. Okay, that's a very important study. That's a Balmer series. Mainly the radiation study here. But now we study the structure of atom, how atoms look like. Okay, we study the structure of atom first. From study the structure of atom, mainly purpose here to study the structure of atom. Structure of atom here. Okay, so Ernest Rutherford, okay, and J.J. Thomson experiment on alpha particle. So Ernest Rutherford. So here the two scientists, Rutherford, J.J. Thomson. Okay, the experiment on alpha particle scattering some radioactive element. Alpha particle scattering on some radioactive element, some radioactive element elements. Okay, in 1906, okay, in 1906, he proposed some classical experiment of scattering. Okay, mainly this classical experiment on scattering. Classical experiment, some at that time only that quantum mechanism was established here. So that's why they actually know that classical mechanism, Newtonian concept. Oh no, they know that. Okay, so that classical experiment of scattering, they experiment mainly on scattering of alpha particle. Okay, and this alpha particle for atomic structure, for study atomic structure. At that time, I think early 1900. Now actually the quantum mechanics is revolved. Okay, now new mechanics is reborn. Okay, so here another two scientists. Okay, Giger and Marsden. These two scientists, uh, Giger and Marsden. Actually, these are the students of Rutherford. Student of Rutherford, they give the birth of Rutherford planetary motion. The student actually, some put the concept here that Rutherford planetary motion. Rutherford planetary motion. Planetary actually not motion, planetary model. Planetary model. So what is the Rutherford model here? Okay, this Rutherford planetary model also that called a nuclear model of atom. These are called a nuclear model of atom. And here, according to this model, center have positive charge. Okay, from Rutherford planetary model, we know that center have, if there is circle, the center have positive charge. Okay, and most means the atom are mass. Okay, so most of the mass, okay, most masses of the atom are concentrated at the center. Okay. If that okay, so here the most of masses of atom, so mainly the masses are concentrated at the center, most mass of atom, most mass of atom are center. Okay, at here. Okay, and these are called nucleus. Okay, clear. What is the nucleus? So nucleus have the maximum masses contained, okay, of the atom. Okay, so and the electron, and here comes some electron, the negative charge, the minus negative charge, the electron here. Okay, and this electron have some orbit, and this electron rotating in that orbit. Okay, around the nucleus, just revolving like a planet. Suppose there is some sun and this is earth, and that is a rotating and revolving here. Okay, there is a revolving here. Look like planetary model. That's why this model is called planetary model. The sun is replaced by the nucleus and earth is replaced by that electron, and these are model is look like a planetary motion. Okay, clear? And these are the basic model of Rutherford model, actually called Rutherford planetary model. Further we study, actually this study is called alpha particle scattering of Rutherford model. Study the alpha particle scattering. Here we study alpha particle scattering. Okay. So alpha particle, so that is which is the helium. Okay. 4, mass number 4 and atomic number 2. And here some alpha particle here. There is some suppose the alpha particle, and here is put some gold foil, very thin gold foil. Okay, and this gold foil and the thickness is very small. Thickness is 2.1 into 10 to the power minus 7 meter. That's a very small thickness of that gold foil. Okay, and uh, here is a detector, and here is a detector, and these are zinc sulfate screen. Okay, and there's a screen and there's a detector screen. Okay, the screen made by zinc sulfate. Okay, when alpha particle, okay, when bombard the alpha particle towards the gold foil, so maximum number of alpha particle passes through the gold foil. Maximum number. There's a minimum maximum passes through that gold foil. Okay, and some particle are deflected here, and rear to rear are deflected back. Okay, suppose that you choose that one in 8,000 alpha particle back uh, in same from source direction, but deflection is more than 90 degree. Okay, almost 180 degree deflection here. Okay, so GJ and Marsden, they use some alpha particle. Actually, sorry, they use not a helium. Okay, they actually use bismuth. Okay, so helium also with alpha particle, but they actually use uh, bismuth. Sorry, so actually they use not helium, they use the bismuth. That the mass is 214 and atomic number is 83. Bismuth alpha particle, and the energy is 5 mega electron volt energy. This huge energy the alpha particle passes through that gold foil, and maximum number of alpha particle are passes through the gold foil, and there is a minimum deflection. Minimum number of alpha particle are deflected. Okay, so thickness of gold foil is very less, that is 2.1 into 10 minus 7 meter order, like that 10 micrometer order. Okay, you know that very small. And if I this diagram for more elaborately drawing, same diagram here, if I put a alpha particle here, and these two are that bricks, lead bricks here, and here I put some screen. Suppose we put some screen here, screen, and these suppose with a gold foil. Okay, thickness is very small. Okay, the gold foil thickness is very small. Okay, and now the alpha particle passes through that lead bricks. Okay, so here you see that maximum or alpha particle passes through the state, and this is a zinc sulfate screen. Okay, and here some 1 million number of alpha particle. Okay, one alpha particle, suppose I say that deflected in that direction, so that angle be the theta, and here we put a detector. Okay, and here one alpha particle backward direction, move backward direction. These are the obvious alpha particle move in backward direction, and I say that 1 in 8,000 alpha particle, obviously these are the backward scattering, 1 in 8,000 alpha particle back in same direction, more than 190 degree scattering. I would say that is 180 degree scattering. Okay, and say the may alpha particle. Okay, if I say that alpha particle do not suffer in collision, max number of alpha particle, max alpha do not suffer any collision, means a collision between gold foil versus alpha particles do not suffer any collision, they just passes through that, passes the foil. Okay, so only 0 point only 0.14% of alpha particles scatter more than 1 degree. Alpha only 0.14% alpha particle are scattered more than 1 degree. Okay, means is very small number. Okay, and 1 in 8,000 are more than 90 degree, are more than 90. In 1 in 8,000 more than greater than 90 degree scatter. So if I draw a graph here, suppose a graph, put here, draw a graph. Okay, and suppose there is a number of particles, if I put here. So here the number of alpha particle, and here is the angle, deflecting angle, deflecting. And you see that this graph is a exponentially decaying graph. Okay, so you see that if I, that is suppose a 10 square, 10 to the power 4, 10 to the power 6, 10 to the power 8, 10 to the power 10, 10 to the power 12, and suppose that at 20 degree, and that is a 0 degree, 40, there's 60, then 80, then suppose a 90, let's say that is as 100, 120. Okay, so here you see that if your deflecting angle is more, so number of particle, alpha particle is less. Okay, so here this point, at that point, so deflecting angle is very high, so number of alpha particle is very less. And here you see that at 0, suppose near about the 0, so number of particle is very high. So this graph actually see that, so angle of deflecting, okay, deflecting angle actually, deflecting angle is very little number of alpha particle are scattered more than 90 degree or more than 120 degree. Okay, if your angle is very high, so number of particle is very less. Okay, so scatter for the Rutherford modeling, that's the concept. Okay, and here there is another concept, that discovery of nucleus. You see the diagram. So you know that alpha being a positive charge. So alpha here, the positive charge. If I put a helium, okay, helium, this is 4,2. So that's a positive charge, and suppose, and now the deflecting back, and we know that if alpha is a positive, and suppose these are the nucleus inside, they have a positive charge, center of that foil, the positive charge. So we know that these are two are the positive charge, so like charge they repel each other. Okay, so that's why they backward, so there is some force, and the concept is that a positive charge, obviously atom contain a positive charge, that's why they deflecting. Okay, so Rutherford concept concentrate on nucleus a positive charge, so maximum mass carry the nucleus and the electron moving the orbit like a planetary motion. Okay, so the concept is like that. So further, so Rutherford concept is, so Rutherford concept is nucleus have positive charge, have positive charge, okay, and carry maximum mass of atom, okay, and obviously nuclear positive charge, maximum mass of the atom, and electron, okay, moving, obviously electron negative charge moving like planetary motion. Okay, so if I the nucleus, so suppose say that is nucleus, so mass and nucleus is very small. Okay, obviously the size of nucleus mainly, the size of nucleus, a rough size of nucleus, say that is 10 to the minus 15 to 10 to the minus 14. These are rough size of the nucleus. So size of the atom is obviously bigger than nucleus. So size of atom, that is suppose 10 to the power minus 10. Okay, very more than the nucleus, but obviously very small. Okay, so atom have, so you see that atom have 10,000 or 1 lakh times is larger than nucleus. Okay, so atom have 10,000 or 1 lakhs. Okay, 10,000 or 1 lakhs or 100,000 times larger than nucleus. Mainly these are the rough idea. Okay, okay. So that means that if electron, and here's that electron, this is a mass of electron is 10 to the minus 31 kg. Almost that's the negligible. They're very small. Okay. So the maximum number of the atom, okay, maximum space of the atom are empty. So final conclusion of verdict is that so maximum space, so maximum space of atom is empty because mass of electron is very less. Okay, so maximum atom is empty, so alpha particle easily passes through it. So maximum atom is empty, so you see that there's an alpha particle, this alpha particle here, this alpha particle, so maximum mass is empty, so atom is space or volume is empty, so the alpha particle easily passes through there. So that's why maximum alpha particle is not deflected. Okay, so here the near that nucleus, obviously maximum alpha particle is not deflected, but near to the nucleus, so here the electric field is present. Okay, actually more the nucleus, the more electric field, so more intense electric field obviously. So if you have more intense electric field, so means more scattering. Okay, so alpha particle is more scattered in towards the nucleus. Okay, and away from nucleus, scattered is very less. The concept is like that. In alpha particle maximum scattered near the nucleus. Okay, so near the nucleus, because there is some intense electric field is generated. Intense electric field. So intense electric field is generated. Okay, so or be present here. So scattering angle is more. So scattering angle is more. Okay, so if you choose a alpha particle with a helium, so mass number 4 and atomic number is 2. Okay, and there's a gold. Okay, so here atomic number of gold is 79. So here we see that the mass of nucleus for obviously that gold, mass of gold nucleus is obviously much greater than mass of alpha particle. Okay, obviously nucleus. Okay, Cl nucleus. Okay, so obviously more. Suppose the 50 times more. So okay, mass of nucleus. Okay, for gold is that 50 times of mass of nucleus of alpha particle. Okay, so here is some force. Okay, if you see that there is a charged particle, so there is a force. Obviously there is a electrostatic force. You know that from first chapter of class 12. So there is a electrostatic force. Okay, so there is a electrostatic force or coulombic force. So obviously that is uh, charge particle of gold, suppose say that is a ZE, and alpha particle, suppose that is a twice E, 2 electron, and here is a 79 electron. Okay, so there is a two charge particle, and if I say that is a nucleus, if I say that is nucleus, so obviously there is a positive charge. But here we see that is from electrostatic force, that is equal to 1 over 4 pi epsilon naught. Obviously that is a coulombic force. Okay, that's electrostatic force. So there is a twice electron. We need only magnitude for alpha particle, and that's for gold by separation from distance between alpha particle to gold foil. That is, I say that is r, so that is r square. Okay, alpha particle and gold foil distance with r. Okay, that's Newton. The force is Newton. Okay, that's the electrostatic force. Obviously there is electrostatic force if an electron revolves, so there is a Newton's second law. Okay, so that's part we will discuss in our next class. Okay, an alpha particle trajectory, electron orbit, calculate energy. Okay, that discussion move in that next part. Okay, next lecture. So today in the class here, if you have any doubt, please ask in comment section. Okay, that's the basic idea of the structure of atom. Okay, how Rutherford Plum Pudding model are generated. Okay, give the proper structure of atom. Okay, so ending of class here. Thank you.